All right, welcome back, everyone. Let's move on to a new division, Division 8. Corresponds to Chapter 8 in your textbook. Now we're going to be dealing with openings. In particular, when we talk about openings, what we're referring to are doors and windows. So let's get on with it. As an overview, we're going to be covering this topic in a single session, unlike some of the other ones. We're going to be covering doors, steel, wood, plastic, some components, types of installation. We're going to be covering windows, also steel, wood, plastic, components, types of installation, curtain walls, and glass and glazing considerations. And you can see the corresponding book chapters for each one of those. So when we talk about general considerations for both windows and doors, some things we need to consider are sound and acoustic considerations. How much noise do you get through? How soundproof is your opening? Glazing, which is the same thing as glass considerations. Heat reduction, more how insulative it can be to keep the heat either out or in. Visible light reduction, filtering of light, security, safety considerations. Can someone break in very easily? And different types of safety as far as how the glass breaks, things like that. We'll talk about that. And aesthetics, what does it actually look like? We have the thermal considerations with the insulation, both surrounding the opening as well as the opening itself. Surrounding the opening, we talk about things like weather stripping, thermal breaks, things like that. Moisture considerations, we talked about this last time, flashing in a way to keep that moisture out. And you can use either flashing or caulk to seal out that moisture. So for example, on the safety consideration, what I see is a fracturing of glass. How's your glass going to fracture? Is it going to come out from these sharp pieces that could cut you, or are they going to be like more granular that don't have sharp edges, or do you need it all to stay impact and not actually leave it all? So all those, based on its application, could be considerations. So let's move on with doors, and starting off with these steel doors. The level of these doors depend on the thickness, or at least that's how they are categorized. So like a level 1 would be a standard, level 2 heavy duty, level 3 extra heavy duty, level 4 maximum duty. And the difference between these is the gauge or the thickness of the metal. Once again, as the gauge decreases, the thickness increases. So this is the lightest gauge at an 18 down to maybe a 16, and you can see how it just decreases from there. So some terminology for these doors in windows. We have astragal, which is the molding attached right here to the edge of the door. Basically, if you've ever seen these French doors, or if you have two doors closing and you have a little piece on one side that'll close that gap so you don't actually see the seam, that's what that is. We have a mullion. It's that vertical member separating panels of glass. Here we see one right here on this door system separating these two panels. It could be glass as well with that center strip. We have a mutton. Same idea, but it could be a short vertical or horizontal piece. Not a picture in here, but we'll see one of those soon. And we have a stile, and the stile is the vertical members on the outside. So it's like this guy here and this one on the other side when I break it down. Let's take a look at some door designs. Starting off with our steel doors, we could have a flush steel door, meaning there is no characteristics, no panels or windows or anything like that. This would be a wooden example, but same idea if it were in steel. Half glass, of course that means half the door is glass. Narrow light, you may have seen these narrow lights, more industrial, when you have a metal door and it's just a thin, maybe 4-6 inch wide window on one part of it, letting just a little bit of light through. Bottom louver, of course these are your louvers, and you could have a wood door. Oftentimes they have the louvers on the bottom. We could have a Dutch door. Dutch door means that they have these two pieces to them that are operating independently, so I could just open the top or I could open the whole thing. We could have a full glass door where the whole thing is 100% glass, a full louver door, something like this guy, or a vision light door. And moving over to the wood side, same idea, flush. Accordion doors, if you've seen these, they actually, like an accordion, they when they retract, it's another word for accordion. Basically, they push together, and your little ridges all come together, or you can pull it closed. A stile and rail door. So we talked about what stiles and rails are with stiles and rails. And panel and sash, you hear terms like this. A sash is like a panel, but it has glass. So you see a lot of these in like French doors. Louvered, just like we talked about with the metal doors, or a wood screen or screen door, right? Moving on with these styles, here you can see some of these. Flush, flush with glass, flush with louver, a full louvered, stile and rail, a sash panel with glass. So I have this glass up here. This is a combination screen storm door where I have screen and 100% glass. French doors, Dutch doors open independently, rolling overhead service doors, rolling grill overhead folding doors. So you've probably seen most of these in different applications, hopefully. Moving on with some more designs that you might see. So you can see a variety of different styles of doors, all depending more on aesthetics than anything else. Sometimes there's some functionality. If you want a certain amount of light in on what part is glass and what part isn't. So when we talk about doors, another way we differentiate is how they swing. We can call them either a left hand or right hand handled door, and basically that's the direction that it's swinging. The idea is that the door belongs to the room that it opens into. So if I were to look at these top drawings, if this was, say, a bathroom on this side, on this inside, well, it is the inside, right? And this is like a hallway out here. This belongs to the bathroom. Now, when it talks about which swing it is or what handedness it is, what you want to do is stand facing the bathroom and put your back to the door. So you face to the room that's going in, put your back to the door, and then whatever side the hinge is on. So in this case, this is, if I were standing here, it would be on my left-hand side, right? Or this would be on my right-hand side. You can have outside swinging doors as well. If we think of it opening into this room here, this is why it says outside. This is my room. Now, this is my bathroom. The door is swinging away from that room. It's still a left hand, but now it's called a left hand reverse, because I'm still facing the inside of the room. But sometimes you'll hear these called outswing as well, right? So either reverse or outswing, but same idea. Left hand, right hand, you're putting your back against it. The in-swing are way more common. This is what you really want to think about 99% of the time. We'll see more examples of these. So when we talk about these doors and identifying doors, we're going to see a bunch of examples just a little bit. What is it made out of? Is it steel or wood? Which of course are the most common. Plastic, okay, could be plastic. Is it flat, or what do the panels look like? How many panels? Is it all the door? Is it half the door? Is there glass? Does the glass cover all or part of the door? Are there any louvers? What direction is it? Is the handling? Is it left-handed or right-handed? Is it reversed? I mean, it's swinging to the outside of the room. So let's take a look at a couple of these. If I look at this guy here, what would I call this? Well, this is a flat panel door, or flush. And as far as the swing, it's swinging into the room, like towards us. So if I were standing with my back against that door, the hinges would be on the left-hand side, so that's a left-handed flush door. What about this guy? Well, where's the room? The room is in beyond this part, right? So if I look, I have these panels. How many panels? 1, 2, 3, 4, 5 panels. So this would be a 5-panel stile and rail, because remember we have our stile and rails. It does have a transom up top. And then the swing, if I were inside, putting my back against this, I would see it's a left-hand swing. What about this guy? Well, this is that Dutch style we said, because it's two different types of openings. It's flush, and it is opening into this room, so it is a right-hand swing. Moving on to this one, we have a 3-panel glass and transom window. What about the swing? It is swinging out. So I would put my, well, actually it's more like a French door, so we don't really identify swing because it's in both directions, right, depending on which side you look at. What about special features of this system? We have this emergency bar here. So the reason those are there is if it was a smoke-filled room or something because of a fire, you couldn't see, you you reach around, you can just find that bar easily, push it open. If you have your hands full or whatever, it's a benefit for that too as well. The other thing I noticed is it has an automatic opener up here, handicap accessible. I have a little switch usually over here, something like that. How about this door? It's basically flush, but it's almost all glass. So I think we call that a vision glass door. And the handling of the door is, if I put my back against it, that'd be a right hand door. What about this door? Well, clearly it's a steel door. Once again, I have access with an automatic opener down here. I have my emergency bar. This is that narrow light window that we talked about. So let's talk about installing doors. We have steel door installation and two different basic frame types around the door. They're either going to be fully welded, which means that the corners and intersections are all welded around this frame, right? Or it's going to be knocked down, which means there's a mechanical joint like screws or some kind of fasteners delivered to the job in pieces, and then it's all manufactured in the process. So it'll come to the job site as one solid frame or put together. This looks like it would be a solid frame. This one looks like it was probably put together, knockdown style, right? Welded, knockdown. Special frame types, we could have a drywall slip-in, storefront, or lead lined, so there's some more terminology. As far as installation, there are a couple of videos. I'm going to let you click on these on your own time, but how to install steel doors in a masonry setting or in these steel studs. Installing all doors, they fundamentally have the same principle where you want everything to be level and plumb. So there's really three different plumb and level you're looking at, right? So you can't have it this way, and you can't have it coming out towards you, and you don't want it this way, and you don't want it crooked in any kind of way. So those are all the different things you're looking at. It's basically getting the whole thing squared up, level, and plumb. So all the videos will deal with that, just a matter of different ways based on your application process you're going for. And of course, if you've ever hung a door, you know that if you have it out of square, it may not close all the way. If you had it out of plumb, your door might just open automatically, or it won't stay closed. Things like that. The one thing about this video that kind of bothered me was they said, well, first you just measure, make sure your frame is level and plumb. If it is not, actually your opening is level and plumb, and if it is not, then do not start the installation. It's like, well, you got to do something. Normally, if your opening isn't level or plumb, you're putting shims in to get the frame at least level and plumb within the opening. But other than that, I think these videos are pretty good. So when we talk about these hollow metal frame, we have to anchor our door some way, and you can see some different anchors in here, from wire anchors or wood stud anchors or steel frame. They're just different anchors. But for these hollow metal frames, the base of it usually has some adjustment to it to get our door at its height and close the gap up top or whatever we're looking at to do. So you would see some of this on the video, but installing hollow metal door frame in an existing opening, you'll hear something called a punch and dimple. And what that means is that when you screw in the frame, it recesses into these dimples, and then you can hide it with some kind of putty or something like that, right? You can kind of see some diagrams going on here with that. So here you can see an example from what it would look like on the project manual, identifying different types of hardware that would be needed on your doors. And from the project manual, here we see a drawing. We can see it talking about the different parts of the doors, from hinges to the mullions and characteristics of them and whatnot. On the drawing, you can identify a door such as this. You'll usually see here's the door, and you have a little bit of a swing. You can tell which direction, left hand, right hand, things like that. So like this door right here would be a left-hand swing, right, into this faculty office. So let's switch gears a little bit, move on to windows. 8.6 and 8.7 from the book. We can have different types of windows, just like we had different types of doors. We can have a double hung, casement, horizontal sliding, a fixed window, or an awning. We'll talk more about these individually on what makes them that. But fixed window means exactly as it sounds. It's just fixed. It's just a solid sheet of glass framed into a wall, doesn't open, right? Double hung looks like this, where I have the two windows. Double hung means that the bottom can go up and down, but also the top can go up or down. So double hung means that both of those should be operable. Single hung will look almost exactly the same, but the top one, usually the top one is fixed in place and only the bottom one goes up or down. So single hung versus double hung, they look the same, but the way they operate is a little bit different. Oftentimes there'll be a weight or something else counterweight that helps keep everything in place, right? A casement window means it's basically encased. The whole window in the frame around the glass is opening up. Usually there's like a crank arm right here, and it opens up as one system. These ones are usually better for sealing out the weather because you do have that solid connection. Of course, not as good as fixed, but horizontal sliding. So panes of glass, and then one side, possibly both, will slide one in front of the other. We have an awning where basically the window is pushing straight out. There's usually some kind of hinge or something like that that is keeping it in place to keep gravity from sucking it back in. Hopper looks just like an awning, only it's upside down, right? So we have it coming out towards us. Basement window looks just like an awning as well. I think the only difference between basement and awning is the direction that it swings, because with the basement window, it's more like egress. You need to get out of the basement, you need to get out the window, so you have it open towards you so there's nothing obstructing it on the outside. That's my understanding anyways. Identifying, describing windows. So what is the material? Just like with doors, is it steel? Is it wood? Is it plastic? How many panes of glass, or how many glass panels are there? So similar to doors, are there separate panels? Does the window open, and in what direction? Vertical, horizontal, sliding, hinged, pivot, multiple panels. We talked about that already. If there are multiple windows together, like an awning window, are they all controlled with the same mechanism? Are there any mechanisms in place that minimize the effort to raise the sash? So this is what I was saying. You might have weights in a wall, and then when you lift it up, the weights are making it easier or minimizing the effort to raise the window. What does the glass look like? Is it treated, tempered, glazed? So you can see some more figures from the book 8.61 and 8.71. Thermal break. So a big issue with windows is insulation. How much of the heat or cold are you going to get through a window? If you have a poorly insulated window, if you've ever stood next to it, you can just feel, if it's on a cold day, you can feel that cold coming right through the window, right? And so we do these thermal breaks to separate these two sides. And so we can see that there's insulation for this. There's two panes of glass. Inside there's a gas or air or something like that, which is a great insulator to keep that part out. The other issue, though, is the metal itself. In this case, we know metals are a great conductor of heat. So if I were to have one side cold, well, that cold would just transmit right to the inside through this metal frame. So to keep that from happening, what we do is we have a little barrier in here of some sort. We have a thermal break or thermal barrier to keep that heat from going through. Curtain walls. So this is going to be covered more with our Chuck Mowry guest lecture. But briefly, what is a curtain wall? This is on the exterior of the building. I see all this glass, right? It's not structural at all. It's not holding any load. It's basically hanging from the building like a curtain. So I can see all these mechanical connections that are holding that glass in place. So this is a stick-built curtain wall. Stick-built meaning I have these horizontal and vertical members that are supporting all of this glazing panels. So the sticks are these individual pieces, just like we talked about stick framing. Versus unitized, which would be meaning the whole thing comes in as one massive unit and just hang it maybe just at the top or something like that, right? So within our curtain walls, we can see that once again we have to have these thermal breaks to keep the heat from transmitting through the metal. So we have the same breaks we saw before. And we talked about U values before. It was the reciprocal of our R value, so R being resistance to heat flow, U is the heat flowing through. and I can measure, that's a measurement of that transfer through glass, just like we have seen it before with our other insulating materials. So moving on with this idea of glass and glazing, and in particular the surface finishing on these doors and windows. With this glass and glazing, when you hear the term glazing, it really just means the part that's made from glass. It could be plastic, but 9 times out of 10 it's just glass, right? Typically made with a soda lime silica, and we have float glass is a flat glass, some kind of thickness between 3/32 and 1/2. So most commonly what you'll see is just a flat piece of glass, also called float glass. Polycarbonate and acrylic plastics are most common plastic glazing materials. Thermoplastics if you have plastic windows instead. Manufacturing the glass and glazing, you can have this process called annealing. And what annealing is it's also done with metals, and it does the exact same thing. And basically you're just rising the temperature, you heat up your glass, and it's freeing any kind of internal stresses that's going on within the glass. And then what happens is you let it lower to room temperature slowly. That's key, to let it slowly so that it will cool to this uniform, and it reduces some of those internal stresses, making it slightly stronger. You can also temper it. Tempering increases the strength of the glass. You might have heard of tempered glass before. Almost the same idea, but you raise the temperature until it starts getting soft. So you get into this, it's called the critical zone, right? You've gone beyond this point where it's almost changing phases. Then you're going to cool it quickly. And you blow these jets of cold air, or you just cool it in some other way quickly, and what that does is it freezes everything in place. So as it heats up, things are moving around on the molecular level, freeze it in place, and you could have either a fully tempered glass, which works like a safety glass. In the fully tempered glass, this is what you see, like automobiles have to have a tempered glass nowadays. If you ever seen like a car window that's broken or anything, you have a bunch of little almost cube looking things, right? It doesn't break in the shards, because those sharp pieces would of course cause damage. So instead it breaks into these round pieces without sharp edges. So that you get that from tempering your glass, or having a fully tempered glass. It's 3 to 5 times as strong as annealed glass for this for loading and thermal stresses and impact loads. You can also have a heat strengthened glass, only partially heat tempered. This is not considered a safety glass because it breaks into larger fragments, but it is stronger. So it's 2 times as strong as annealed glass for uniform loading. So not as strong as the fully tempered. It's basically like your intermediary step for a heat strengthened as opposed to fully tempered. Less expensive process overall though. So a big part of our glazing that we need to consider is our heat reduction and light absorption. So often we can add a coating onto the side of our glass, and what that does is it'll reflect out a large portion of this heat and light to keep it from getting into our building envelope. And as it says, it's a metallic oxide during this manufacturing process. You can also tint glass, which is basically like a film that you can put on the outside. It can result in light absorption that reduces visible light but does not reduce UV light. So in essence, making the room darker but not cooler. You can have light reducing glass, which is just the tinting you put on the outside. You could have light reducing and heat absorbing glass. So it depends on what you're looking for. Do you want your glass to reflect the heat, absorb the heat? Do you want it to reflect the light or absorb the light? So those are the 2 variables you're playing with these processes. So you can also laminate your glass, basically putting multiple panes of glass together, creating a composite. Composite just means made of multiple layers glass. You could have 2 sheets of glass with a single plastic inner layer. The reason you do this type of thing is to encase the glass. So I can see that, like with the tempered glass, I said it would break into these small shards. If you had laminated glass, I can encase it so that it doesn't actually leave. It just shatters and it stays right there. So if you saw the new Tesla truck, I know that was something that, and Elon Musk throws the thing and breaks the windows. And you end up with this spider webbing like this. So that was a laminated glass. Of course, it was supposed to be much stronger than what he showed, but regardless. So burglar resistant, bulletproof, acoustical, things like that. This is the reason you would use this laminated glass. Made from bonding layers of glass with inner layers of polyvinyl, butyryl resin, or polycarbonate resin. And you can have multiple thicknesses from down to 1/4 inch up to like 3 inches. When we talk about this glass, you can have different types. You can have an insulated glass, and I mentioned this earlier where if I have multiple panes with a gas in between, it has this insulating process because air is a natural insulator to keep the heat from moving from one end of the other. You can also have wired glass, which is like a safety glass, usually more in commercial applications where I can see there's wire inside the glass. I always think of a school building when I see this, right? But or old buildings from the 60s and 70s. But that wire mesh keeps the glass in place if you were to break the glass. You can look at the surface finishes of glass, so more of a aesthetic appeal. I see some finishes on here where you can etch your glass or sandblast the glass to change its transparency, so you get like this more opaque look, right? You can enamel your glass, which is like firing at a high temperature, silvering, make it look like mirrors. Basically, all a mirror is glass with a coating on the back side, right? With the silver coating on the back side. Reflective coating, control the heat into buildings. So we talked a little bit about that earlier. So here we see putting it all together for the insulative properties and everything else. We have aluminum frame, and then we have our glazing. Then we have a gas in between our glazing, which is our glass, right? So we have glass, glass, glass. This is a triple pane with 2 air pockets in here. The air is composed of argon, which is a good insulating gas. Warm edge spacers. So once again, this is insulating between the inner and the outer. More insulation down here. Air seal down here, and then we talked about this thermal break to keep the metal from transmitting heat from one side to the other. We have this piece in here, right? And once again, you can look at the project manual and get more specifics, such as manufacturers that are approved for a project, different types of finishes, or if it needs to be wired or not, and what type of specifications that wire needs to meet. So that's what I have. As usual, let me know if you have any questions or comments. I'll talk to you all later. Thanks.